Hey guys, clustering is most popular type of unsupervised learning approach. It falls under unsupervised learning. Clustering is basically where you group data, cluster data, untagged data based on their similarities and differences. And one of the most popular algorithm which falls under clustering is k-means clustering. It's like playing a game of find the groups with your data where k represents number of groups that you want to find, you want to create out of data. In this video, we will understand the best unsupervised learning technique, which is for sure is clustering. Specifically, we will be talking about k-means clustering algorithm in detail. There is one more type which falls under clustering named as agglomerative clustering, but that's for another discussion in the next video. For now, let's talk about clustering technique and k-means clustering specifically. So let's get started and talk about what is k-means clustering algorithm and how it works. Hey guys, welcome to AI with AI. This side Asif Imnad. If you remember, in the previous videos we discussed about different machine learning types: supervised, unsupervised and reinforcement learning. These are three broad classifications of machine learning. And we have already covered tons of unsupervised learning algorithms and the videos. I urge you to watch our supervised learning playlist first. Today onwards, we are starting with unsupervised learning algorithms. We have already discussed different types which falls under unsupervised learning. For now, let's jump in and talk about clustering techniques, specifically k-means clustering algorithm. Definitely, k-means is a part of unsupervised learning family. This means it doesn't rely on pre-labeled data. Data is untagged, unsupervised data, which automatically identifies patterns and similarities and finds groups within the data. So this is what the objective of clustering is. The primary objective of k-means, if I talk about, is to partition data points into clusters so that each point belongs to the cluster with the nearest mean. In other words, it seeks to minimize the distance between data points and their cluster centers so that it can find groups and it can create a clusters out of the data. Something like this in the image that you see. So the concept is really easy. Let's understand how k-means clustering really works. On screen you see a step-by-step explanation of how k-means clustering really works. There are 5 steps involved into this. The very first step is to identify the number of clusters required, which is k. K stands for how many clusters do you want. So first you get the data, and from the data how many groups, how many clusters do you want to create. So that k stands for number of clusters that you want to create, which is a hyperparameter that user needs to set. Then second step is to randomly initialize the centroids. The centroids are the centers of the clusters. They can be initialized randomly or using a more sophisticated methods which we will talk about in a short. The third step is assign each data point to the cluster whose centroid is closest to it. Now the algorithm starts finding the data points which are closer to the centroids, and this is done by calculating the distance between each data points and each centroid, and then assign that data point to the specific cluster which is closest to the centroid. And the fourth step is to update the centroids so that you get the average of all the data points within the cluster. And finally, the step 5 is to repeat the step 3 and 4 until the centroids no longer change. Let's understand this with a really simple example, and this is going to be really interesting. Pay attention. So assume this is your data. This is how the data looks like on the screen, which is unlabeled. Definitely the data is plotted against X and Y, something like this. Unlabeled data, unclustered data currently. Let's say we assume value of k as 2. That means we want to group this data into 2 clusters, into 2 groups. So in such situations, what algorithm does, it drops 2 seeds, something like this. Seed 1 that you see is in red color, seed 2 which you see is in blue color, right? So it drops 2 seeds because we want to form 2 groups. So now what algorithm does is it finds the nearest data points to this red one and they become red, and similarly it finds the data points which are closer to this blue seed and they will be converted to blue. Basically it is assuming the data points which are closer to red are nothing but red, and the data points which are closer to the blue one are the blues, something like this, as you can see. In short, data points which are nearer to red seed will become red, and the data points which are closer to blue will become blue, something like this, as you see. And in the next step, what this algorithm does is it moves these seeds to the center of the group which has been recently formed. So this blue seed will be moved to the center of the blue data points. Similarly, the red seed will move to the center of the red data points. So this is how it identifies the centroid. Once these seeds are moved to the center of the clusters, it will again reset the color. Now again the same step, what it will do? Now again it will ask the same question to the data points. Are you closer to the red? The data points which are closer to red will become red, and the data points which are closer to blue will become blue, something like this, as you see in the image. Now again these seeds will start moving towards the center of the cluster 1, and similarly the blue one will start moving to the centroid, that is to the center of this blue data points, something like this. Once they shift into the centers, again it will reset the colors, and again it will ask the same question, asking are you closer to red? So become red. Are you closer to blue? Become blue. So again the data points which are closer to red will become red, and the data points which are closer to blue will become blue, something like this. And you know what, it will just keep repeating the same process again and again. So if it keeps doing the same thing again and again, eventually it will form two groups, and the centroids, these two seeds will not move further, and this is how it will form two groups, two clusters, something like this. So one cluster which belongs to red, and the second cluster which belongs to blue. Now if you try to move this seed to the center of the cluster, it will not move because it is already at the center. So once you keep repeating these steps, it will eventually identify the most identical situation where it can form two groups by identifying centroids. This is how K-means clustering works, and isn't it really easy? Isn't it amazing? I hope I made it really clear. Just to understand quickly, let's revise once. We want to create two clusters, that's why we dropped two seeds, red and blue. Now it will ask the question to all the data points, are you closer to red? If you are closer to red, become red. If you are closer to blue, become blue. So the data points which are closer to red will become red, and the data points which are closer to blue will become blue, something like this. Now the next step is to move to the center of the red and move to the center of the blue. These seeds will move to the center of each group, something like this. Okay, and it will reset again. So once they move to the center and the colors are reset, so now it will ask the same question again, who are you closer to? So the data points which are closer to red will become red, data points which are closer to blue will become blue, something like this. Okay, so these steps will keep repeating again and again unless and until it finds the best center and the best groups and ultimate centroid of the two different clusters. And once you keep doing it, eventually the time will come where these seeds will not move further. And this is when you can see you have identified two different clusters, that is two different groups. I hope you understood this. So where does this K-means clustering is used? Let me give you some real-time examples. K-means clustering is used a lot in customer segmentation. You have bunch of people, but you want to target your product to the specific people based on their gender, based on their age, based on their ethnicity, so on and so forth. So unless and until you do not group them, you do not understand your customer, you do not segment your customer, it will be difficult for you to target the specific audience to sell your product. So customer segmentation is one of the area where clustering is used a lot. So in the example you see, we wanted to find 4 clusters based on their age, gender, ethnicity, and let's say demographics. And this is how it will form 4 groups, 4 clusters, and now you can target your product to the specific group. So in a conclusion, K-means clustering is a simple but powerful unsupervised machine learning algorithm that can be used to group data into clusters. It is a versatile algorithm that can be used for a variety of tasks such as customer segmentation, market segmentation, image segmentation, wherever you need grouping of data when you have unlabeled data, when you have unsupervised data. In the next video, we'll be seeing the demo with scikit-learn and Jupyter Notebook, so stay tuned for that. If you are new here, don't forget to hit that subscribe button and the bell icon so that you won't miss our latest videos on AI. We see you guys are watching our videos, but most of you are not yet subscribed. We put a lot of efforts creating these videos for you free, Keep us motivated by liking and subscribing so YouTube algorithm will help reach us more audience. And that's how we come to an end of this video. If you have any questions, concerns regarding this topic, the concept that I've discussed, let us know in the comment below. If you found this video helpful, please subscribe and hit the like button. And yes, don't forget to share this with your friends and the colleagues. Thanks for watching. See you again next time. Till then, take care. Bye bye.